Swayam Prabha. Digital India. Educated India.
Welcome back, my dear friends. A very good morning, good afternoon and good evening to all the students and the participants for this NPTEL MOOC course, and this is the TQM2 lecture series, and this is lecture number 20, as you can see in the slide. 20 means that we will be halfway through after this lecture and completed about 4 weeks. Each week you have 5 sessions, each session or lecture, whatever you mention, is for half an hour. Now, if you remember, we were discussing after in the fag end of the 19th lecture, and also I did mention as we were proceeding that given the factors which will affect your the interrelationship of the factors and their effects. So, we had considered in detail 2 problems. One was basically etching problem depending on the power, and one was basically the material used for the temperature for the battery. Now, in the initial example for the etching problem, and though in between these 2 examples I did mention though briefly the smelting process of aluminum. So, it can be thought about different type of examples in the same light. We did consider that there were only 2 factors, point 1. Point number 2, when we consider the factors effects were coming by from A, factor A, which has numbered the suffix was I from 1 to small a, factor B which were numbered j is equal to 1 to small b, and K basically denoted the number of observations which was basically from 1 to small n. And similarly, if I found out the degrees of freedom, we found out the total sum of squares. So, they were basically coming from A, B, then from the errors, and some of them was the total errors. Then we considered the concept of later on in all these examples, the concept of the mean squared error. Based on the mean squared errors, we found out that was found out by dividing the sum of the squares divided by degrees of freedom. We found the mean square, the ratios of the mean square in different formats gave us the f value, and we basically either rejected the null hypothesis or accepted the null hypothesis based on what the problem formulation was. Another important thing which we should remember is that whenever we are considering the factors, we did consider that there was a mean value mu, which was basically average of the average or the average of the average of the average, depending on how many such factors were there. If you remember, I did mention that time and again. And we also had the concepts that when you are considering the average of the average of the average of the average of the average, we took the best estimate, which was mu hat, which was basically either the average value of y taken one time, that is y bar or y bar bar, y triple bar, and the suffixes which were I, j, k. If there was a dot, we assumed, I know I am repeating, but please bear with me. If it was a dot in the suffixes, it means that we are summing them up for those rows or columns or the number of observation which you have. So, if factor was along the row, so obviously A was along the row, so the suffix would be, the dot would be the first dot. If the summation was along the columns for factor B, the dot would be the second dot. And if you are basically summing up for all the observations, I and j keep varying, like I is equal to 1, j is equal to 1, then you sum it up, then I is equal to 2, j is equal to 1, sum it up, and all these combinations, we had a dot in the third place in the suffixes. Similarly, we went to the effect of trying to utilize the capital T statistic, which is Stucky's test, and then the Bartlett's test were there. Then we consider the concept of tau i's, beta j's. Tau i's are the variations happening for the factor a's. Beta j's were, because the suffix would make it very clear, I being for factors 1 to small a, which is for capital factor a. Then beta j was basically for all the factors along the columns from j is equal to 1 to small b. Based on that we calculated, and we then, if there was a combination to extend it, we consider it is tau into b suffix ij. Then in the later part, which I am coming, and we will be discussing more in details, we consider there were 3 factors a, b, c, and then we consider tau, beta, gamma, then tau I, beta j, gamma k, and k was from 1 to small c for the factor c, and L was basically the last suffix was basically for the number of observations 1 to small n. Then we in the last, if you pay attention to the last slide in the 19th lecture, that was a detailed one, but it was very easy to understand. The first column was the factors, their effects and their total sums, then come the degrees of freedom column wise, then we had the mean squared errors, then you have the F statistic, and then basically whether it was greater or less than, we commented whether we accept or reject H round. So, based on that we again continue. The sum of the squares is found out like this. So, here I will try to highlight and use the highlighter. So, you are summing up for all the 4s I, j, k, l. So, here if you note down, there are 4 dots, and the summations are I is equal to 1 to, I is here, sorry, I is equal to 1 to small a, j is equal to 1 to small b, which is for factor b. Similarly, I was for factor a. For factor c, it is k is equal to 1 to small c, and for the observations L is equal to 1 to small n. You add up. So, these are the sums of the squares you want to find out. So, this is the sum of the total squares. You use this formula, find it out, and then put your calculations accordingly. So, these are the squares of each observations. These are the square of the average of the average of the average of the average. You are taking average 4 times, and then divide by A, B, C, N, which are the total observations. So, your total set of observations will be A into B into C into N. So, the sum of the squares for the main effect are found from the total of the factors from A, from B and C. And why we are naming, giving the suffixes, I will make it clear to you. So, if you note down here, A is for factor 1, the first one. So, obviously, it will be summed up for j, k, l. So, if you find out, the first one is I, the second, third, fourth are dot, dot or dot, because you are summing up. If I go to the B one, so obviously, B is basically for the column or the second factor. So, obviously, dot should come in the second place, dot should come in the first, third and fourth place. Sorry, my mistake. So, j would basically change, and the summations would be done for I, which is A, for k, which is C, and for L, which is N. Similarly, when I take the third factor C, the summation would be done for the first, second and the fourth, and k would be fixed, and then the summations would be done, which is for A factor I is equal to 1 to A, B factor j is equal to 1 to small b. So, A and B are small b's, A's and B's, and third place is changing because that is j, and then the summation being done for L is equal to 1 to small n. So, you find out sum of the squares for A, B, C, which is the first factor, second factor, third factor. Then when you sum them up, when you utilize this, so corresponding values would become very simple to understand. So, for A, it means that you are keeping A at ith level and summing up for the second factor, third factor and n observations. This is what it is, dot 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 in the second, third, fourth place, and for the sum of the squares it will be divided by B into C into N. For SSB, which is sum of squares for B, Here the second suffix would keep changing, but it will be summed up as I am repeating it for the first, third and the fourth places as rightly done here, and it will be divided by A into C into N. And for SSC, the summation would be done for each value of k, it will be done for the first, second and the fourth as it is shown here, and the division would be A B into N. Similarly, you have these values coming out here y square, and the total set of observation is obviously A into B into C into N. So, you find out SA, SB, SC. So, you can find out combinations of AB, AC, BC, and then summing up all these things and subtracting the whole sum from SST, which is the total, will give you the sum of the square of the errors. Now, coming, that is what I did mention. So, let us go slowly step by step. To compute the two factor interaction sum of the squares, the total for A into B would be one combination, A into C would be the second combination, B into C would be the third combination. So, now we need to find out the sums for these three sets of combinations. It is frequently helpful to collapse the original data table into two-way tables. So, consider this, when there were two factors A, B and N, it was a matrix and it was a cube sort of thing, cube or a cube or whatever, and you took the slides and slices. So, if you are taking the slice along the vertical as I am showing, then obviously it will mean that if I am measuring A along this direction, so which means I keep A fixed, and summing up for all the slides would basically mean I am summing up for B and also which is the second factor for N. If I am looking at the orthogonal direction from this side, from my left hand side, which means I am taking slices like they are happening and they are slowly moving away from me, but they are parallel, which means that I am basically keeping B fixed, which is J fixed, summing out for A factor and N. Now, if I and for the case when I am basically trying to find out for A and B at I and J value N, it means that I try to find out for any one cell all the sums. If I go to a higher dimension, now it is not a cuboid or a cube, but basically there would be three axes for one for A, one for B, one for C, and obviously N would basically also come into the picture because it is the total number of observations which you have. So, if you are able to visualize the first case when there are two factors and observations is N, it will be very easy for you to understand how the formulations are done for the higher factors, right. In this case we are considering now 2 at a time, then finally consider 3 at a time also. So, let me continue. So, the sum of the squares can be found out, as I mentioned, is that to collapse the original data into three two-way tables rather than combining them as the matrix. So, here the sum of the squares would be A B, that is combined effect of A and B. It will be, now if I extend it, it will be y square. Now, I would pause and think that if it is A B, which means that I am trying to take the factors of A and B considering C, which is the third one, is being summed out for the whole set. Similarly, the number of observations for N is basically being summed out for the whole set, and rightly pointed out is where I am going to circle is this. If you see, I and J are corresponding to A and B, and the third and the fourth dot correspond to the fact that C is not being considered in the picture because you are summing up for all the factor values for C and for all the values of N. And obviously, the second term obviously remains minus with the minus sign y square in the suffix dot 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 dot, that means you are summed up for all the 4 I j k l divided by A into B into C into N. So, and in the total sums obviously would mean that you have to subtract the individual sum of the errors also coming from A individually and B individually. So, which are what I am going to mark now with a different color. So, it will be easy for us to to just note it. Yes. So, this would be SSA, which you have already found out, this is SSB. So, they would be subtracted in order to find out SSAB. When I move to the sum of the square AC, the concept exactly remains the same, you only replace B with C. So, if I am basically replacing B with C, so obviously it will become this concept, this part which I will now use black again, red again, yeah. This remains same as this part, while I use a different color green. So, this is SSA remains same, SSB replaced by SSC because it is now a combination of A and B, and in the extreme left, the term onto the right hand side of the equality would be, let me use another color, well let me continue the highlighted one. So, if you notice this and this, they are exactly the same, only the concept of B has been replaced by C. So, it was B, so obviously the sum would have been for all the C's and N's. So, now it is C, so all the sums would be for B and N. If I go to sum of square of BC, obviously now the A factor would be there. So, this is 1 by A n divided by n, and the summations are for j is equal to 1 and k is equal to 1 to respect values of B and C, and y square would mean that if you are taking B and C, so obviously B and C is the second and the third would be j and k, the first and the fourth would be summed up, so hence they would be dot. The term of this, yeah, so the term y square dot 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 remain the same, and the values of SSB and SSC are just the replacement which you have. So, note that the sum of the squares for the two factor subtotals are found from the totals in each two-way table. So, you are basically into two-way tables. The three factor interaction sum of the squares is compounded in a similar way. So, what you do is that you find out the sum for all I j k dot. So, obviously, it will be divided by n, and I would be summed up from 1 to small a, j would be summed up from 1 to small b, c would be summed up from j is equal to k is equal to 1 to small c, minus the value which you found out y square dot 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 divided by a, b, c and remain the same. And now you have to basically minus the values which is SSA, SSB, SSC individual, then combination of SSAB, SSBC, SSAC, which are coming like this, SSAB, SSBC and SSAC. And finally, now if I go to four concepts, so obviously in the sum here I will just repeat it slowly. You had A, B, C, D. So, if it is A, B, C, D, so obviously you would have the sum of the squares of A, B, C, D, and what would be coming out here? Let me go one by one. So, let me mark it as 1. So, 1 would change to 4 summations. So, I1, I2, I3, I4, where I1, I2, I3, I4 change from 1 to small a, 1 to small b, 1 to small c, 1 to small d, considering the factors are capital A, capital B, capital C, capital D, and obviously 1 by n remains outside. So, inside what you have where I am marking my this pointer would be y square. Now, rather than 4 dots there would be 5 dots, the first dot for capital A, second dot for capital B, third dot for capital C, fourth dot for capital D, and the last dot for n, which is observations. Division would be A into B into C into D into n, small n. Now, what factors you will negate from there would be first singular one, SSA suffix value, SSB suffix value, suffix I am mentioning for A and B's, SSC suffix value. Now, you will consider the combinations of 2 taken at a time, it will be AB. So, you will have AB, then AC and AD. So, combination of A changing B, C, D will come. Then combination would be BC, BD, then would be CD. So, you will basically have the combinations as shown. So, it will be taken 2 at a time for 4. So, basically it will be 4 C 2, which is factorial 4 by factorial 2 factorial 2. So, 4 into 3 into 2 by 2 into 2. So, 3 to 6, 1, 2, 3, 4, 5, 6. So, 6 are done. Now, we will come to the combinations of 3 taken at a time. So, obviously that will be 4 C 3 factorial 4 by factorial 3 by factorial 1. So, it will be 4 into 3 into 2 and this 3 into 2, which is 4. So, what are the 4 combinations? It will be A B C, A C D, B C D, and the combinations you will have the last one and combine them accordingly. And the last term would basically be the combination of A, B, C, D. So, they will all come up and you can do your calculations accordingly. So, a soft drink bottler is interested in obtaining more uniform fill heights in bottles produced by his manufacturer process. The filling machine theoretically fills each bottle to correct target height, but in practice there is a variation around this target and the bottler would like to understand the source of this variability better and eventually reduce it. The process engineer can control 3 variables during the filling process: the percentage carbonation, A, operating pressure or lines for pressure for filler, B, and bottles produced per minute, which is in the line speed, C. The pressure and speed are easy to control, but percentage carbonation is more difficult to control during actual manufacturing process. However, for process of an experiment, the engineer can control carbonation at 3 levels: 10, 11 and 12 to 14%, and she chooses 2 levels as pressures 25 and 30 psi pound square inch, and 2 levels of speed, which is 200 and 250. She decides to run 2 replicas of a factor design in these factors with all 24 runs taken in deviations in random order. The response variable observed is the average deviation from the target filled height observed in a production. A run of bottles in each set of conditions are considered. The data thus results from this experiment are shown in the table 5.113. Positive deviations are fill heights above the target, whereas negative are fill heights below the target. The circled numbers in this table is the 3-way cell together, which we just mentioned. So, I, J, K, L would be the nomenclature. So, operating pressures B is there. So, you have for 25 psi, 30 psi, and the percentage carbonation which you see in the first column, which is 10, 12 and 14, and the line speed being 200, you had the values given as -3, -1, 0, 1, 5, 4, and for line speed corresponding to 250, you will have the values of -1, 0, 2, 1, 7, 6. Similarly, you have for 30 psi line speed of 200 and 250, the values are -1, 0, 2, 3, 7, 9. And I am not reading the circled one, which I did mention what the circled one was in the last slide. Those and the line speed for 250 were 1, 1, 6, 5, 10, 11. The values are 2, 11 and 21. And the yi dot that means summing up for a j, for k, for l were coming out to be -4, 20 and 59. Similarly, when I go into the combinations of B and C total values, B and C would obviously mean that we are keeping J and K fixed and you are summing out for the first factor A and the number of observations. So, those values are given and the combinations values are found out to be 6, 15. So, I am reading these values 6, 15, 20 and 34, and the Y value comes out to be the Y summed up value comes out to 75. Similarly, for combinations of A into B and A into C, the values are given. So, the A and B values, A is 10, 12 and 14, B values are 25, 30. Then A, C combinations are given, A values are 10, 12, 14 and C values are 200 and 250. So, the total corrected sum of the squares is found out, which is 336.625, and the sum of the squares of the main effects are calculated from equations as we have already discussed. The values are like this. So, for the sum of squares of the carbonation is 252. I am just reading without the decimal. For sum of the square of the pressure, it is 45, and the sum of the square of the speed is 222. So, these are the effects. Now, I want to find out the combined effects. Combined effects, if you find out for A and B, this value minus y square, that and then 4 dots means summation in the suffix, divided by A into B into C into N, minus SSA and minus SSB. So, SSA and SSB would be coming from here. Let me mark it. So, these are basically the values which I have. So, that value gives me SSAB as 5.5 point something. I am again not mentioning the decimals. Similarly, I follow the concept and do the calculation on SSAC. The value comes out to be 0.583. I have to read the decimal because it is in the decimal case here, and for the value of SSBC, it comes out to be 1.042. When I go into the third stage for combination of A, B, C, I find out the summation 3 times I, j, k, n is divided outside, and then I find out y square, divide y square, divide dot 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 4 dots, dividing by A into B into C into N, minus SSA minus SSB minus SSC, minus of SSAB minus of SSBC minus of SSAC. The value comes out to be 1.083. So, with this I will close this 20th lecture and continue this example. This is the first time I am not able to finish this example. I will continue with this example in the 21st lecture. Thank you and have a nice day.